All right, so next we're going to set up our alignment of our instances. We're going to use normal and up vectors to start this off. I appreciate some of you probably already know this stuff, but I just want to make sure we're all in the same place before we move on. So currently our scattered points don't have any normal attribute. We can add this just by coming up to our file cache. We can put down a normal SOP. We'll set it to point mode. If we enable our visualizer, we can see we now have point normals on this. So when we scatter our points on, these normals will be inherited by those points. So now we have normals, Houdini will recognize this attribute and it's going to align our geometry so that our forward Z direction of our input mesh is facing along that normal, just like this. So on our geometry here, this would be our forward Z direction going down here. And this is now what's being lined up along our normal. Just to make this a bit easier to see, let's colorize our box and make this easier to see our axes. I'm just going to put down a primitive wrangle. I want to color our faces rather than our points, so I'm going to use primitive here. I'm going to set our CD attribute, which is our color, to be equal to our normal attribute. So it's going to take the middle of the normals of our each face and it's going to copy that to the color, which gives us our red, green and blue. On the back though, unfortunately, it gives us black, not actually black, but they're negative colors. Because the normals in these directions are facing in negative directions, they're giving us actually negative values. If we come up here and just split our pane top and bottom, and if I just right click on this and choose Inspector's Geometry Spreadsheet, you can also press Alt-8. If we come to our primitives, you can see we've just copied those values straight across, but these negative values here are causing us the issue. So it's easy to fix. We can just use what's called the absolute function, which is ABS. Returns the absolute value of the argument, and all that's going to do is it's going to flip any negative values to be positive. Anything that's positive is going to stay positive, so it's essentially just flipping things into the right space. Just to make it a little bit clearer for the two different sides, we can also say if, let's go for the minimum of our normal attribute. So of the three components, X, Y, and Z, it's going to find the minimum. And if any of those are negative, so if they are less than 0, we can just set our CD to be equal to 1 minus CD. And 1 minus CD is just going to give us our complementary color, or the invert. So where on one side it's red, the other side is now cyan. Where one side's green, we've got magenta. Where one side's blue, we've got yellow. I'm also just going to scale this face in a bit here. So I'm going to press S, make sure we've got our primitive selected. Tap E to scale and just bring that into a little point so it's a bit more obvious now. So this blue little point along here is our forward Z direction. And if we look at our copy to points now, zoom in here, you can see that this is now lining up along our normal. So that's all good, but we still haven't set up anything that tells Houdini how the instance is going to be rotated around that normal. For example, here we've got our normal on, let's see, this one here, pointing in the right direction, but there's nothing to say how this is going to spin around that normal. You could almost think of the normal as like an axle of a car, and then the instance being a wheel. It's fixed in this direction, but it could spin in any direction around there. We haven't set up anything to control this yet. But luckily that's what our up vector is going to do. It's just another attribute that Houdini will look for, and if it finds it, it's going to align our y-axis of our input geometry in that direction. So just to remind ourselves, in our case, our y-axis is this green face here facing up. So let's add this to our setup. Just to actually demonstrate this, I think I'm going to do this on a grid initially just to make this a bit easier to see. Then we'll come back and add this to our setup that we have now. I'm going to put down a grid. just going to scale that in a little bit so it's a bit smaller. I'm going to put normals on that. I'm going to copy the node over. I'm going to copy our scatter as well. I'm just going to turn off our density so we have points scattered like this. Because these have normals, when we wire this in to our p-scale and through to our copy to points, you can see we have all our clones facing upwards. And just as it happens, because this is a flat surface at the moment, our y-axis, which is the green one, is just facing in our -z direction. So we could put down an attribute create. We're going to create an attribute called up, all lowercase. It's going to be a vector. And if we were to set this to say 1 in x, so this is x, y, z, let's just set it to 1 for x. Just going to make sure we have a visualizer on that. Let's click up. You can see our green axis is now pointing in our positive x direction. We could set this to be -1. Now it's facing the opposite direction. We could set it to be z. Now it's facing in the z direction. Hopefully you get the idea. We could even do a bit of a more contrived example. Let's just put down another grid. Scale this in a bit more. Just give that normals as well. So if we have point normals facing up, we can actually override this and just instead call it up. So now this is our normals. We can transform this. And then we could just simply use an attribute transfer to copy this to our input points. So if I copy that in there, enable our points and just select up. Now we could, in fact, I'm going to turn this visualizer off. We can rotate this just using our plane. So you can see as I rotate it, it's basically just rotating our green up axis. Hopefully this makes sense. Of course, these don't have to be the same. You could even just add a attribute randomize. Again, we could just set it to up. It's dimension 3 because it's a vector, and we could just set the distribution to be inside sphere, which will give us random directions in 365 degrees. So you can see this is now our up vector. And you can see these are now sort of randomly rotated in all directions. It's important to note as well that even though our up vector is pointing in all directions, we're still always going to have our normal facing, or sorry, our z-axis facing along that normal. It's never going to shift from its position. All this is doing is just rotating around that normal. So I hope that makes sense. I've gone a little bit maybe over the top explaining that, but I just wanted to make that perfectly clear. Let's just drag this back to our original setup. So we have this. Using the normal this way, sorry, using the up vector this way is a little bit hard to control. So in the next lesson, we're going to look at how we can use what's called quaternions to make this a little bit easier for ourselves. It's a little bit more work to learn, but it's going to make rotating our normals and rotating our up axis a lot easier. For now, I'm just going to disconnect these ones. I'm going to go back to our original attribute create here, and I'm just going to set it to be the up. So we're going to set the up attribute to be 1 in Z. So you can see they're pretty much mostly facing down this Z axis now. So we'll come back and we'll look at quaternions next.